Welcome back. Uh, that segment of recording in the past one was a bit too long, so I decided to break it up and continue now on my slides. So let's take a look at this slide. So technically speaking, you can potentially represent document and the terms that you're going to use inside a term document matrix, TDM, or document term matrix, DTM. Here is actually quite easier to think of tweet. Tweet are supposed to be sentences, short sentences, and you are going to have terms inside that are supposed to be meaningful. Based on the rule of a tweet, you're not supposed to write 10 pages of document. Therefore, you want to use the best that you can on the tweeting that you do. You try to avoid using anything that has no meaning for the audience. So you make the most of it. That's the intention. Now, tweet 1 has term 2 and term 3. Tweet 2 has term 2 only. Tweet 3 has term K 3 times. So I need you to keep in mind, at this time, we are now counting. So when I say, I love you and I want to make breakfast for you, I have 2 I's and I have 2 U's, and I'm counting. Not only the existence, but also the number of appearance that is going to be inside. Bag of words model is basically, when you take a look at my statement, if you take a look at my statement here, when I say I like football, if I have not pronounced it to you, my sentence, I like football, and if you were taking a look at this table, would you say that I said football like football like I football? There is no order in the words that has appeared in my document. I am a human being and I'm using a sentence, and when I use a sentence, I put the words right after each other. But in a bag of words, imagine you have a bag and you have words inside. It's like Legos, you put them inside. They're all scrambled. There is no order in my bag of words. So that's what we are trying to basically refer to. Word order are lost. Grammar is lost. Footballs, F capital, likes, whatever it is. We don't have footballs, by the way. There is no S at the end of football. And the way we are going to actually process that is called term frequency inverse document frequency, TF-IDF. It's a simple numerical outcome calculation that I need to have in order to have some sense. Remember, I'm a computer. Some sense of what that means, okay? Let's begin. Bag of word model. It is a puppy, and it is extremely cute. As you can see, I have 2 it and it, and I have 2 is. I don't see any is. If there was an is, it would have been 2. I don't have an A, that would be 1. Puppy is going to be 1, and I don't see and, that should be 1. Is again should have been somewhere. I didn't. Extremely, that's going to be 1. Cute is going to be 1. So if you take a look at my limited snapshot of my 2,000 rows, 1 million rows of words, I have 2 it, I have 1 puppy, I have and, I have 1 cute, and I have 1 extremely. What order? It doesn't even tell me what order it is. And of course, the meaning, the sense of it, the feeling of it is lost in that process. But that's the way computer is supposed to translate a text into a bunch of numbers. What is TF-IDF? Okay. The value of frequency of a word in a document, I'm going to actually give you an example in a moment. So for example, if I take a look at this, I have, in document 1, I have the word love. I have 12 times the word love inside that document. It's a love letter, right? It's a love letter, and I'm going to be impressing my partner in life, and I'm using love a number of times. So that's 12 times. But how significant is it? How significant this TF is going to be? For me to understand the significance of the word love in my document, okay, is your document about 20,000 words and you only use love 12 times? If your document is 30 words and you use love 12 times, do you see the difference? So if you have 10,000 words in that document and you have used love only 12 times, that may not necessarily be as significant as when I wrote a short love letter to my partner in life and I wrote 50 words, and in 50 words, I had 12 times I wrote love. That seems to be more significant. So the way I'm going to calculate the TF, I'm going to actually calculate 12 divided by the number of words that exist in that document. So it's going to be 12 divided by 50. 12 divided by 10,000. That's going to be the significance. The value, the inverse document frequency, IDF, is going to be based on the number of documents that contain the word. So if you take a look at this one, for example, I seem to have 25 documents. I wrote 25 love letters to my partner in life, okay? So imagine I wrote 25 love letters to my partner in life. How many times did I say love in those documents, 25 love letters? I might just have said love in only one of them. So that would be 1 divided by 25, right? So, or in another way, we are going to say 25 divided by 1, but since the number is too big, we are going to take a log behind it. I'm going to explain that in a moment in terms of formula and in terms of the example. So first, I need to understand the significance of the love in a single document. 12 times love in a document that has 50 words, 12 divided by 50. I normalize it. Then I'm going to take a look at, so this is vertical. This is vertical. This is about vertical. I'm going to sum them up, and the number of words in that document is going to be 50, 50. So the summation here is 50, and I'm going to say 12 divided by 50. That's one thing. Now, I'm going to go horizontal now. And because this row is not properly explaining what I'm trying to say, I'm going to focus on this row, if you don't mind. Now, if this is the case, I have used meeting, the word meeting, only once in 25 documents I had. I wrote 25 love letters, and only in one of them I said, let's meet. Let's meet. So that's going to be 1 in relationship to 25. And the way we are going to do that, 25 divided by 1, that's 25. And then you do the log behind it so that you have the lesser number. That's going to be the IDF. So let's take a look at the formula. TF, 10 frequency, the frequency of X in Y. And remember, this is normalized. This TF, X and Y, you need to count the number of love versus the number of words in the document. 12 divided by 50. Then you're going to say, I have written 25 love letter, that's N, and only I wrote in one of them, I love you. In 24 of them, there is no indication at all of any word called love inside. So what is it? This is 25 divided by 1. Maybe among the 25 love letters that I wrote, it's going to be 25. Maybe I wrote love in 4 of them. 25 divided by 4. Maybe I wrote love in all of them. 25 divided by 25. So that's what this one is going to be, okay? And that's going to be 1. And this is log in base 10. So when you say log of 25 divided by 25, generally speaking, it means you have used so many times the word love that effectively you made it useless because it seems to be so much common, this approach. This approach is telling you this, that it is the same as it is, as is, I know, because they have been used so many times that you have become desensitized. You are desensitized toward the love term, Okay, let me give you an example, and then we could potentially go basically here. Now, here is an example. If you take a look at this example, I have a document 1. This is a sample. Imagine A has twice appearance in that document. This is another example. Again, just for the sake of a study, assume that another is appeared in that document twice, an example appeared in that document 3 times, and the way we are going to calculate that. So let's take a look at the this, THIS. This in document 1, you have 1 divided by 5. So the summation is 1 divided by 5. I normalize it, it's 0.2. When I take a look at this, its significance is reduced because you have 3 examples, you have 2 another, and obviously the weight and existence of this is going to be lesser than and the document number 1. So you have 1 divided by the summation. This summation is going to be 7. 1 divided by 7, 0.14, and 0.14 is less than 0.2. So that's the significance of the word this. Now, I have used this here in document 1, and I have used this here in document 2. How many documents am I talking about? I'm talking about 2 documents. How many times it has appeared? Once in this, even if it is 10 here, even if this is 10, we count it as 1. It's about appearance, and this is about appearance. So this is counted as 1 when I do calculation horizontally. Remember that. It's not 2, it's 1. So when I say this is this here and this here, I would say you had only 2 documents and the word this appeared in both. So what's the significance of this? 2 divided by 2 is 0. So let's take a look at this. This has no specific meaning in this example, in these 2 documents. So as you multiply by 0, you're going to get 0 and 0, and that's going to basically make this appearance kind of meaningless. I'm not going to pay attention to it. That's what it means. Now, if I wanted to take a look at example, in D1, of course, I don't have any. So the occurrence of example in document 1 is going to be 0. Occurrence of example in document 2 seems to be very significant. 3 divided by 7, 0.429. And if I wanted to find the IDF, you have 2 documents. You have 2 documents, and only in one of them you had seen example, and that's why I wrote 1. So 2 divided by 1, 0.3. Remember, this is log base 10, and therefore example D1 and is going to give me 0. There is no example here anyway, so there is no significance here. But in document 2, there is significance, and the significance is going to be 0.129. I want to stop here, and then I'm going to continue in the next recording the rest of the slides of this session.